Hello, good evening, learners. I'm reading edition of our discussion on factorization. So let's set the ball rolling. If we talk about factorization, one key thing that should come to mind is that we are looking at resolving the mathematical expression we have into factors. So if you are asked to factorize, you are going to resolve any expression that will be given you into factors. When we talk about factors, then we are looking at products of numbers. So for instance, if I have 12 and I'm asked to list the factors of 12, we are looking for all numbers that can divide 12 and there will be no remainder. So understand that 1 is a factor of every number, 2 can divide 12 and there will be no remainder, 3 can also divide 12, there will be no remainder, 4 can divide 12, there will be no remainder. And you get to this point, 3 times 4 should produce 12. So if you want to get a next factor, look out for what number times 2 will produce 12, and that is 6. And then 1 times 12 will produce 12. So when you're looking out for the factors of 12, we are looking at 1, 2, 3, 4, 6, and 12. So if we are going to factorize expressions, we are going to make sure that our final answer is going to be factors of the expression we are factorizing. So in that case, for instance, if you are looking at 12, you look at 1, 2, and 6. These are factors of 12. In the sense that if you multiply 1, 2, and 6, it is going to produce 12. Now, let's set the ball rolling. We are going to take mathematical expressions. So, for instance, let's start from 2a plus ab. 2a plus ab. If you are asked to factorize 2a plus ab, the first thing that you'd have to watch out for is which of the factors in the two terms is common. Which of the factors in the two terms is common. Mind you, remember 2a has to do with two factors because the product of 2 and a produces 2a. Whilst AB has to do with two factors because the product of A and B produces AB. Now, out of these two factors in both terms, which of the factors do you see as common? Without any reservation, you can see A appearing in both terms. So obviously A is the common factor of both terms. If A is the only common factor, it comes out. Now, we are looking for the other factor. So it means that if you are looking for the other factor or factors that should be able to help us factorize, then it means that we are looking for another expression or another factor which would multiply the a to produce the result of 2a plus ab. So in that case, you take the first term, 2a. If you take the first term 2a, divide 2a by the common factor a. So in that case, a divides a1, a divides a1. 2 times 1 should produce 2. You take the second term, ab, divide by the common term a. A divides itself 1, a divides itself 1. 1 times b is a b. A b out of 1 would also produce a b. So in a nutshell, I have been able to factorize the expression 2a plus ab into a and then 2 plus b. So if you were to multiply a and 2 plus b, it should produce the result of 2a plus ab. Let's take another example. P squared q minus 4pq squared. 6p squared q minus 4pq squared. In situations like this, you realize that with the minus, it tells us we have two different terms in this expression. So we have to look out for the common factors. Now, for you to be able to produce the common factor, you would have to treat the number part of your terms separately. So for instance, the number parts of these two terms are 6 and 4. Look out for any number or the highest number that can divide 6 and 4 without a remainder. Obviously, it's 2. So 2 is part of the factors of this expression. Then now you pick p squared and p in both terms. At least you are looking out for a variable that can divide p squared and p without a remainder. Obviously, it's a p. You pick out q and then q squared. You are looking for a variable that can divide q and q squared without a remainder. Obviously, that will be a q. So if you take them in bits, you'll be able to get the common factor in due course. So at this juncture, we just realized that our common factor is 2p and q. 2p and q. So our common factor is giving us one of the factors that we seek to resolve the expression into. So if you want the other factor or other factors, sometimes you can produce 3 different factors. If you want the other factor or other factors, you are going to divide each of the terms by the common factor. So in that case, we work it out here. We pick 6p squared q and we divide that by 2pq. Realize 2 can divide itself 1, divide 6, 3. The p squared has to do with p times p. And realize p would take off one of the p's, and q would also divide itself 1. So we are left with 3p out of 1, which means our first term in the other factor is 3p. If you want the second term, you pick negative 4pq squared. You divide that by the common factor 2pq. Realize 2 can divide itself once, 2 can divide 4 twice. P divides itself once, p divides itself once. The q squared, don't forget, it means q times q. So q will take off one of the q's. And what we have left is minus 2q. By so doing, you have been able to factorize these expressions. If you understand this part of our lesson, this should be your trials. Factorize the following. First question, 3p squared q squared r minus 9pqr. Question 2, m squared nq plus mqr squared. In our next meeting, we are going to look out for how to factorize an expression that has 4 terms. Bye-bye.